Hello, welcome back to Husky Math. Today we will learn about trigonometrical transformation. So in these problems, differentiation is usually the easy part, okay? The real challenge is transforming and simplifying the given trigonometric expression into a form where differentiation becomes direct. This chapter is less about applying differential formulas and more about simplifying and then differentiating. So here are some formulas from class 11 from the chapter multiple angles and submultiple angles. So let us revise few formulas here. As we all know that sine 2x equals to 2 sine x cos x. So here if you notice that whenever the angle is 2x, then on the other part there is the angle x and x. That means this x is half of 2x. Okay, that means if I have to write the formula for sine x only, then I can write 2 sine x by 2 cos x by 2, because from here I can see that whenever the angle is given, then we have to write the half of it, that is the half of 2x is x and x. That's why I'm writing sine x equals to 2x by 2, because x by 2 is the half of x and x by 2 is the half of x. So that's why this is called submultiple angles. Okay, so in this way we can rewrite the formulas for every given function here. So in number 2, we can see that cos 2x equals to cos e square x minus sin e square x. And we have a few formulas for cos 2x, that is cos 2x can be written as 2 cos e square x minus 1. So from here, I can write 1 plus cos 2x equals to 2 cos e square x. That means if I have to write this as 1 plus cos x, then I will write 2 cos square x by 2, because here's also the same logic, because whenever the angle is 2x, then here it is half of it, that is x. So if I see 1 plus cos x, then I will write the half of x, that is x by 2. So 1 plus cos x will be 2 cos square x by 2. And from here also I can see that cos 2x equals to 1 minus 2 sin square x. So I can write 1 minus cos 2x equals to 2 sin square x. And hence this can be written as 1 minus cos x equals to 2 sin square x by 2. Sorry, there is square here. Okay, so these are two important formulas or transformation we should remember here. 1 plus cos x can be written as 2 cos square x by 2, and 1 minus cos x can be written as 2 sin square x by 2. In the second part, there is a direct formula, that is sine of 3x and cos of 3x. We have formulas written over here. And in the last part, that is sine 2x and cos 2x, we have written the formula in terms of tan. So sine 2x equals to 2 tan x over 1 plus tan square x, and cos 2x equals to, in terms of tan, will be 1 minus tan square x over 1 plus tan square x. So these are the few formulas which we have to remember, and we will be requiring more formulas from trigonometric functions. Okay, for example, the complementary angles like sine 90 minus x equals to cos x. So this kind of formulas also we will be needing, and also like sine of a plus b. The formula for this is sine a cos b plus cos a sine b. So these all formulas we will be requiring in this chapter. So let's start a question. Question number 1. Cot inverse of square root of 1 plus cos x over 1 minus cos x. So let my function y will be equal to cot inverse of square root of 1 plus cos x minus 1 minus cos x. Here we will first rationalize the given function, whatever is there inside the square root. So before differentiating, let us simplify the given function. So let us rationalize 1 plus cos x over 1 minus cos x by multiplying and dividing with 1 plus cos x over 1 plus cos x. So it will be cot inverse of square root of 1 plus cos x whole square, and in denominator we will have 1 square minus cos square. So then it will be cot inverse of, now see, square root of 1 plus cos x whole square will be simply 1 plus cos x only, and in denominator we will have square root of 1 minus cos square x can be written as sin square x, because we know that sin square x plus cos square x equals to 1. So my function will be cot inverse of 1 plus cos x over sin x, as square and square root got cancelled. Now let us use the formula. We know that 1 plus cos 2x had formula 2 cos square x, and we know the formula of sin 2x as 2 sin x cos x. Therefore it will be y equals cot inverse of, see, 1 plus cos x can be written as 2 cos square x by 2, because whatever the angle is there we have to write the half of it, whole divided by sin x can be written as 2 sin x by 2 cos x by 2. So here 2 and 2 got cancelled, and cos square and this cos x by 2 got cancelled. So then we will have y equals to cot inverse of, see, inside the bracket we have cos x by 2 over sin x by 2, and cos by sin is cot x by 2. So this implies y equals to, see, cot inverse of cot x is simply x, then we will have only x by 2. See, now up to here we just simplify the given function. Now we will differentiate both sides with respect to x, then we will have dy over dx equals to ddx of x by 2 will be 1 by 2 only. So this is the answer. See, at the last step only we did the differentiation. So it's more about transforming the trigonometrical equations into its simplest form. Question number 2. We have cosec inverse of 1 plus tan square x over 2 tan of x. This is cosec, okay, C-O-S-E-C. So let y equals to cosec inverse of 1 plus tan square x over 2 tan of x. We have one formula, that is sin 2x equals to, in terms of tan we had 2 tan of x over 1 plus tan square x. Now if I flip the fractions on both sides, then we will have 1 by sin 2x equals to 1 plus tan square x by 2 tan x, and 1 over sin means cosec, so this will be cosec 2x equals to 1 plus tan square x over 2 tan of x. Hence my given function, that is 1 plus tan square x, is simply cosec 2x, because that fraction is here inside the cosec function. That means my y equals to cosec inverse of cosec of 2x, and cosec inverse of cosec theta is theta only, that means y equals to 2x. Now we will differentiate both sides with respect to x, then my answer will be 2. Question number 3. Let y equals to cot inverse of cosec x plus cot x. So cosec can be written as 1 over sin, plus cot can be written as cos over sin, and simplifying the fraction inside, then we will have 1 plus cos x by sin x. Now this is the question which we had done in question number 1. So y equals to cot inverse of 1 plus cos x can be written as 2 cos square x by 2 over sin x is 2 sine x by 2 cos x by 2. Cos gets cancelled, 2 got cancelled, hence my function will be cot inverse of cos by sine means cot x by 2. So the given function is actually x by 2 only, and if I differentiate both sides with respect to x, then we will get the answer as 1 by 2. Question number 4. So from here the question is a little bit different, because see, inside sine inverse function there is variable x only. So here we have to assume x as another trigonometrical functions, okay? And since there is 1 minus x, so it would be better if we assume this x as cos theta, because we have formula for 1 minus cos theta. So here in this question I will assume, so first let us assume y equals to sine inverse of root over 1 minus x by 2. Now I will suppose this x as, let us put this x as cos theta. Then my function will be y equals to sine inverse of root over 1 minus cos theta by 2. See, the purpose of putting x equals to cos theta, because we have the formula for 1 minus cos theta. So here it will be y equals to sine inverse of 1 minus cos theta can be written as 2 sine square theta by 2 whole divided by 2. So here this 2 and 2 got cancelled. So that means y will be equal to sine inverse of, see, square root of sine square theta by 2 is simply sine theta by 2. And sine inverse of sine will get only theta by 2. Now since we had assumed x as cos theta, but my function was given in terms of x, that means we have to transform this theta, because x equals to cos theta, that means theta will be equals to cos inverse of x. This is actually, we are operating both sides by cos inverse function. So now let us replace the value of theta, then we will have theta equals to cos inverse of x by 2. Now we will differentiate both sides with respect to x, then we will have dy over dx equals to half ddx of cos inverse of x. Therefore dy over dx will be equal to half, and ddx of cos inverse x is minus 1 by square root of 1 minus x square. So my answer will be minus 1 by 2 root over 1 minus x square. Question number 5. So here also we can see that inside sine inverse function there is x, so we will assume x as another trigonometrical function. So let y equals to sine inverse of 3x minus 4x cubed. See, we had one formula, direct formula, that is sine of 3 theta, that is 3 sine theta minus 4 sine cube theta. So if you see that this particular expression and this particular expression is somewhat similar, that's why we will assume, we will put x as sine theta. Then we will have y equals to sine inverse of 3 sine theta minus 4 sine cube theta. And that means this is the formula for sine 3 theta. That means my function became 3 theta only. Now let us put back the value of theta, and the value of theta from here is theta equals to sine inverse of x. Therefore my function will be y equals to 3 sine inverse of x. Now we will differentiate at last, that is dy over dx will be 3 into ddx of sine inverse of x, and ddx of sine inverse of x is 1 over root over 1 minus x square. So this is the answer. Question number 6. Let us put x equals to cos 2 theta. Then my function y will be equal to sine inverse of square root of 1 plus of cos 2 theta whole divided by 2. Let us distribute the denominator also, minus square root of 1 minus of cos 2 theta over 2. So this equals sine inverse of 1 by 2. Square root of 1 plus cos 2 theta can be written as 2 cos square theta minus 1 by 2. Square root of 1 minus cos 2 theta is 2 sine square theta equals sine inverse square root of 2 by 2 into square root of cos square theta is cos theta minus square root of 2 by 2. Square root of sine square theta is sine theta. So this equals to sine inverse of, now if I have to write this is square root 2 by 2, then I can also write 1 by square root of 2, because 1 by square root of 2, if I rationalize this fraction, then it will be square root of 2 by 2. So this is the purpose of writing this. So here also I will write 1 by square root of 2 sine of theta. So this equals to sine inverse of, now we know that sine 45 degree is 1 by square root of 2, that is sine 45 degree cos theta minus, and again here also I can write cos 45 as 1 by root 2, because cos of 45 is also 1 by root 2 sine theta. So the purpose of writing this was, now this has become sine A cos B minus cos A sine B. So this is the formula for sine A minus B. So there's one formula, that is, so this formula, so this is in the form of this. Therefore y can be written as sine inverse of sine A minus B, that is pi by 4 minus theta. Therefore y can be written as, now this sine inverse of sine will be simply pi by 4 minus theta. Therefore I can write y as pi by 4 minus theta can be written as you can see from here, that x was cos 2 theta, that's why 2 theta can be written as cos inverse of x, and theta can be written as cos inverse x by 2. So here I can write 1 by 2 cos inverse of x. Now let us differentiate both sides with respect to x, then we will have dy over dx equals to, see, ddx of pi by 4. Pi by 4 is a constant, so it will be 0, and here it will be minus 1 by 2 ddx of cos inverse of x, and the differentiation of cos inverse function is minus 1 by square root of 1 minus x square. Hence my final answer will be 1 over 2 into square root of 1 minus x square. Question number 7. Tan inverse of 1 plus x over 1 minus x. So let y equals to tan inverse of 1 plus x over 1 minus x. Here let us put x equals to tan theta, then my function will be tan inverse of 1 plus of tan theta over 1 minus tan theta. So this can be written as, we know that tan 45 degree is 1, so instead of this 1 I can write tan 45 degree plus tan theta whole divided by, let us write this 1 as it is, minus, here this minus tan theta I can consider this tan theta as 1 into tan theta. So instead of that particular 1, I can write tan 45 into tan theta, because tan 45 is 1 and 1 into tan theta is tan theta only. Now this is in the form of one formula, that is tan of a plus b equals to tan a plus tan b over 1 minus tan a tan b. This is in the form of this, so I can write this everything as tan a plus b. So my function, that's why, will be y equals to tan inverse of tan a plus b. My a is pi by 4 here, plus b is theta. So that's why the function will become pi by 4 plus theta only, because tan inverse of tan x is simply x. Now let us replace the value of theta. Then my function will be y equals to pi by 4 plus, so from here I can see that theta equals to tan inverse of x. So here it will be tan inverse of x. Now let us differentiate both sides with respect to x. Then ddx of pi by 4 is 0, plus ddx of tan inverse x is simply 1 by 1 plus x square. So this is the required answer for this question. Question number 8. Let y equals to sine inverse of x into square root of 1 minus x minus root over x into root over 1 minus x square. So here I will consider this x as sine a and this square root of x as sine b. So I'll consider this x as sine a and this square root of x as sine b. So put this x equals to sine a and square root of x as sine b. So if I square both sides, so it will be x square equals to sine square a, and if I square both sides in this equation, then it will be x equals to sine square b. Okay, now my function will be y equals to sine inverse of, now instead of that x I am writing sine of a square root of 1 minus, and instead of this particular x I'll write this sine square b. So it will be sine square b minus square root of x is sine b, square root of 1 minus, now instead of this x square I'll write sine square a. So it will be sine square a. So y equals to sine inverse of sine a square root of 1 minus sine square b is cos square b minus sine b 1 minus sine square a is cos square a. Hence my function will be sine inverse of sine a square root of cos square b is simply cos b minus square root of cos square a is cos a, and there is sine b here. Now this everything is in the form of sine a cos b minus cos a sine b. So this is the formula for sine a minus b. Hence my function will be sine inverse of sine a minus b. Therefore y equals to a minus b only. Now let us put back the value of a and b. So this will equal to, now since x equals to sine a, that's why a can be written as sine inverse of x, that is a is sine inverse of x minus, since square root of x is sine b, so b can be written as sine inverse of root x. So this everything I did from here, x equals to sine a and root x equals to sine b. So now let us differentiate both sides with respect to x. Then we will have ddx of y equals to ddx of sine inverse of x minus ddx of sine inverse of root over x. dx of sine inverse x is 1 by root over 1 minus x square minus, here using the chain rule, I'm considering root x as x, then it will be dx of sine inverse of x, that will be 1 minus of x square. So here it will be root over x square, and again I have to differentiate root x here. So my final answer will be 1 by root over 1 minus x square minus 1 by square root of 1 minus square root of x square is x into the dx of root x is 1 by 2 root x. So this is the final answer. Question number 9. Y equals to sine inverse of, let us distribute the fraction, then we will have 5 by 13 into x plus 12 by 13 into square root of 1 minus x square. So here we will put this 5 by 13 as sine A and this x as cos B. Now using right angle triangle, we'll try to find the value of cos A. Since here, as you can see, sine A equals to 5 over 13. We know that sine of any angle equals to perpendicular over hypotenuse. That means my perpendicular is 5 here and my hypotenuse is 13. If I consider this angle as A, and here's my 90 degree. Now using Pythagoras theorem, we know that hypotenuse square equals to perpendicular square plus base square. So this will be 169 minus 25 equals to base square, and it will be 144 equals to base square. That means square root of 144 is 12. That means my base would be 12 here. So in this triangle my base is 12. So if sine A equals to 5 over 13, then my cos A will be equal to, see, cos means base over hypotenuse, and here my base is 12 and hypotenuse is 13. That means 12 by 13 I can write as cos A. Therefore my function will be y equals to sine inverse of 5 by 13, I will write sine A, and x I have considered as cos B, plus 12 by 13 is cos A, and square root of 1 minus x square, that is cos square B. So y equals to sine inverse of sine A cos B plus cos A square root of 1 minus cos square B is sine square B. Hence my function will be sine inverse of sine A cos B plus cos A square root of sine square B is sine B. Now again, this is in the form of sine A plus B. So my function will be sine inverse of sine A plus B. So it will be A plus B only. Now let us put back the value of A and B. Say 5 by 13 equals to sine A. So from there, the value of A can be written as sine inverse of 5 by 13 plus, since x equals to cos B, therefore B equals to cos inverse of x. Now let us differentiate both sides with respect to x, then we will have dy over dx equals to, see, sine inverse of 5 over 13 is a constant, so the derivative of constant is 0. Then we will only left with ddx of cos inverse of x, and the derivative of cos inverse x is minus 1 over 1 minus square root of 1 over square root of 1 minus x square. So this is the answer for this question. The last question for this video and from this chapter, from this topic. So here also I will consider root A as tan of A and square root of x as tan B. So on doing so, my function will be tan inverse of square root of a is tan a minus tan b over 1 plus square root of a into x is the square root of a into square root of x. That's why it will be tan a into tan b. Now this is in the formula of tan a minus b. Hence I can write this everything as tan a minus b. So y equals to tan inverse of tan theta is theta only. So y equals to a minus b. Now let us put back the value of a and b. Now since root a equals to tan a, so a can be written as tan inverse of square root of a minus, since square root of x equals to tan b, therefore b equals to tan inverse of root x. Let us differentiate both sides with respect to x. Then it will be, see, a is a constant here. That means tan inverse of root a is constant. So the derivative of that portion is 0. Then we will have minus ddx of tan inverse of root over x. Again, by the chain rule, I will consider this as x. Then it will be dy over dx equals to minus ddx of tan inverse x is 1 by 1 plus x square into ddx of root x. So dy over dx equals to minus 1 by 1 plus x into ddx of root x is 1 by 2 root x, and hence writing my answer properly, then it will be 1 by minus 1 by 2 root x into 1 plus x. So trigonometric transformation is done here. In most of these problems, simplifying the trigonometry was more important than actually differentiating the function. Okay, next we will start implicit functions. So that's it for this chapter. See you in the next one. Bye bye.